Good morning, good morning, good morning. We are mixing up the intro here on a Monday morning. It is Monday, the 23rd of March, 2026. And today we are going to go through yet another A-level math paper. I quite liked what we did last time with the Edexcel series, and I wanted to carry on with that, do another demonstration, show some of the techniques. I think it's really good as we're moving into exam season for you to see an entire paper, which will help with that kind of broad-based revision in case there are any individual topics you guys are having any issues with. And really importantly, that exam technique, including the checking at the end, that I think is always extremely helpful. So as usual before, if there's anything I think you guys really need to see with the calculator, I'll make sure, in fact, I'm going to put you on the second screen already because I just realized I do not have my calculators up and running yet. So anything that you particularly need to see with the calculator emulator, I'll make sure to get to you guys. If it's just a case of just inputting something, I'll just run it manually. I think you guys are going to be fine if it's a more basic function. And yeah, I think we're just going to get into it. Calculators are ready to go. Papers are ready to go. And I don't see any point in dillying nor dallying any further. So let's get into it. We'll be going from here. Oh, in fact, no, let me stop that. Let me do entire screen so that you can get the calculator if you need to. We're turning on the, there we go. Turning on the little thing. Cool. So let me put 2 hours on the clock just so that I have it, just so I can kind of track the timing. So stopwatch, no, timer, 2 hours. I don't know why it's always preset to 110. And as always, if you guys have things in the comments, please, no spoilers. I will be checking the comments, and like no spoilers. But if, you know, like after a question, maybe. Hello. You got me to say it. I was going to mix it up. And okay, because I like legit had this conversation with someone over the weekend where I was like, I can't stop myself. So hold on, story time. So like with the intro, I like sometimes I go through and I'm like, okay, let me just like go through the videos and I'll open them up. And I'm bombarded with hello, like every single time. And I'm like, oh, I find myself very annoying in this moment. And I'm like, do you know what? I am a grown adult and today is the day I make the change. And then every single time, start on the microphone, hello. And I'm like, okay, calm, it's Monday morning, relax. Meet the moment where it is, Patrick. You don't need to be doing all that. Nothing wrong with it. Now, on a Wednesday, you can't stop me. But also, this is I'm feeling tired. Like we're just feeling a little bit more mellow today. We're feeling a bit more relaxed. And I thought, you know what? Let's not come in at 100. Let's come in at a 60, and just sort of see how we can vibe with it. But anyway, let's get into it. Sharing entire screen. Paper one, ready to go. You see, I can in fact count to 1, guys. That's how you know you can trust me. And let us. Why? I literally. I swear the tech is teching. All right, let's go. So first things first, let's make sure you can see this. Let's make sure it's zoomed in. Nice. Okay. So nice standard integral to start with. So that is the integral. First thing we have to do is get that in differentiable form. So I'm going to write that as a third. I'm going to write that as 2. That third is going to go into 2x to the 3 over 2 minus 5x to the half. In fact, why? Why did I do that? No, we're not doing that. Let's just put the third into those fractions. So that'll be 2/3 x to the 3 over 2 minus 5/3 x to the half. That I prefer. All right, so we're going to raise this power to 5 over 2 and divide by 5 over 2, which is the same as multiplying by 2 over 5, which will turn that into 4 over 15. X to the 5 over 2. I agree, easy. To start with, it's going to get harder. Give it time. So the half will be raised by 1 to 3 over 2. Multiplying by 3 over 2 is this, dividing by 3 over 2 is the same as multiplying by 2/3. Turning that into 10/9 x to the 3 over 2 plus c. Great, done. Okay, cool. Next. Right, so okay, so we have this function. Given that x minus a is a factor of x, that means f of a is equal to 0. So I'm going to write that right off the bat. So I'll copy down what f of x is, because I don't want to have to write it like on the paper itself. So it's 4, in fact, let me zoom out just so I can write it down. So it's 4x cubed plus 5x squared minus 10x plus 4a. And we are told that f of a is equal to 0. So 0 is equal to 4a cubed plus 5a squared minus 10a plus 4a. So 4a cubed plus 5a squared minus 6a is equal to 0. And you can factorize out the a right off the bat. Great. And that was exactly what I needed to prove. Nice and simple. Hence, find the value of a. And use algebra, well, to find the value of a. So obviously a equals 0 is a solution, but does it specify that a can't be? Yeah, but a is a positive constant. Because a is positive constant. Okay, so that means to find any other ones, we have to solve the quadratic, 4a squared plus 5a minus 6 equals 0. And I'm going to use, my sort of little special method that I learned from the IB side of things. 4 times the minus 6 gives me a target number of minus 24. And I need factors that add to 5. So that would be plus 8 minus 3. So I'm going to do 4a plus 8, 4a minus 3, and all of this over 4, where the 4 will cancel with the first term to give me a plus 2, 4a minus 3 equals 0. So a is equal to minus 2, which is not a positive constant, or a is equal to 3/4, which is the answer. Use algebra to find the exact solutions. I know, right? It's a really interesting method, but it saves a lot of time. Because you don't know with a 4 whether it's going to be 1 and 4 or 2 and 2. And I just quite liked it. I just find it quick. So I always need, because the alternative here, and I'll show you this while we're here. So the alternative, once you found your plus 8 minus 3, the way that I was taught at A level was I would rewrite that middle term as 4a squared plus 8a minus 3a minus 6 equals 0. And you can factorize in pairs. So that becomes 4a into a plus 2. And then you've got minus 3a that you can factor out of here to make an a plus 2, which gives you 4a minus 3 into a plus 2. So this it's a perfectly valid method. But I picked this up from the IB, and that's how they do it there. And I just it's faster. I just quite like it. So I've sort of learned to do that. But yeah, you've learned something today. Play around with it. See if you may not feel comfortable doing it if you don't think they're going to accept it in the mark scheme, but you know for yourself that it works now, and that's what counts. So for part 2, what can we do? We are going to use algebra to find the exact solutions of the equation f of x is equal to 3. So I'm going to have to, is that for that value of a? Yes, it must be. So for that value of a, it's going to be plus 3 at the end. So I'm going to say that then f of x is equal to 4x cubed plus 5x squared minus 10x plus 3. And again, high chance of a transcription error, so I'm just going to confirm. 4 plus 5 minus 10 plus 3. 4 plus 5 minus 10 plus 3. That's written down correctly. And we're trying to solve for that thing being equal to 3, which means that 4x squared, 4x cubed, don't be the, nope, no transcription errors today. So transcription errors are where you see the thing and you just write it down wrong on the next line. And today is not the day. Not having it. I want a nice, simple run without any silly mistakes like that, which means, of course, I'm going to make some horrendously silly mistake later on. Does this factorize? I wonder if I could do this by inspection. So that's minus 40. Are those factors? Which are 5 apart. Minus 40. 8 and 5 are 3 apart. 10 and 4 are 6 apart. Am I going to have to... Well, exact solutions. I wonder if... I don't think that factorizes, you know. So it would be x equals 0. Unless I've done something horrendously wrong. You can see, like, I'm always sense checking. Like, does this make sense? It's plus 4a. And 4a is equal to 3. Which I found 2 ways. So, and that's... Yeah, this all tracks. This all tracks. So either x equals 0 or x is equal to minus 5. Yeah, I know. Yeah, I was literally just getting there. 25 minus 4ac, so plus 160, which is minus 40 times 4. Yeah, the square root of 185 is not a thing. All over 2a. So I'm going to say minus 5 plus or minus, so because it says exact form. But let me check it. So I'm going to calculator it just in case it comes out as something special. Minus 4a c. No, that does not c. This is c. Oh, God, I shouldn't. All over 2a. And yeah, no, 185 does not simplify. So I'm just going to leave it like that. I mean, is that in the line? No. Should you write in the line on your real thing? Yes. Yeah. So I'm just using the calculator. But what you'll see when I get into the checking phase. Now, in the real thing, I wouldn't check it immediately. So I won't do that now. But I'll show you in the checking phase, just putting those answers back in and making sure I get the answer I want. It'll be fine. So here, relative to a fixed origin, we've got some 3D vectors. So the point A has that position vector, point B has that position vector, magnitude of OA. So, well, that's just easy. That's done by Pythagoras. So the square root of 5 squared plus 3 squared plus 2 squared is, do we even have to go through it? 25. So it's 4 and 9 is 13 on the 25 is 38. Done. Find the smallest value of A for which the magnitude of OB is bigger than the magnitude of OA. Well, let's find the magnitude of OA. So magnitude of OA is the square root of 2 squared plus 4 squared plus A squared, which is the root of A squared plus 16 plus this, let's say 20. Now we need the root of A squared plus 20 to be less than the root of 38. Well, if that is true, so the magnitude is strictly positive. So if the magnitude of that is bigger than the magnitude of that, that also means the magnitude of this squared is bigger than the magnitude of this squared. So I think that also means that A squared plus 20 is less than 38. Unless I've done something incredibly silly. Which would mean that A squared is less than 18. So the smallest value of A, given that A is a positive integer. No, that implies I've done something wrong, though. Because that it can't just be 1. What have I done? Did I put them on the wrong side? So OB. Oh, that's OA. That's OB. Okay. I got them on the wrong side. But it's right. I caught it. Caught it. Okay, so what would have helped there? So I made that little execution error. What could have helped that? If I'd rewritten the vectors. Because then I could have tracked it, right? So OB, oh, it's because I rewrote it wrong. That wasn't OA. So that's why, okay. But it's right. You see, I caught that with the sense check, right? I could see it was going wrong because I was like, well, it can't just be 1. Okay, so that's OA. So it doesn't matter if you make silly mistakes as long as you catch them. So similarly, the root of A squared plus 20 must be bigger than the root of 38, which means that A squared plus 20 must be bigger than 38, which means that a squared must be bigger than 18. And so the minimum value of a must be 5. Because 4 only gets you up to 16, and it's a positive thing. And for 2 marks, I think that's good enough. So moving on to question 4. Let's zoom out so we can read it. Curve C has equation. I can be silly sometimes. But everyone can be silly sometimes. And so this is not showing you how to do a perfect run, but this could still be a run where I get a perfect score because it's about catching your mistakes. Every mistake I make is instructive. And also, even if that mistake is as instructive as get some sleep or you make silly mistakes. I have one of those mornings, you know, when you like wake up one sleep cycle too early and then your brain's just like, what if we didn't go back to sleep? And you're like, please. And it's like, no, we're doing not that. I thought about that. We're doing a different thing. And I'm like, oh, fine. So we're getting that version of me today, but that version of me can still do math. Because also, you never know. Something bad might happen to you the night before an exam, and you're still going to have to find a way. And I'm going to stop soliloquying, whatever that verb is. So we have a curve. The curve has the equation y equals f of x. Oh, we got a whole bunch of nonsense. So use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Okay. So we have a derivative. We know there's a stationary point with x coordinate alpha. So we know that f dash of alpha equals 0 and alpha is small. Right. So what that means, given that f dash of x is 2x plus a half cos x, well, we know that f dash of alpha equals 0. So equals 2 alpha plus a half cos alpha equals 0. And if alpha is small, we use the small angle approximation. I'm curious, in the mark scheme, do they give it to you? I don't think so. That feels like something you're supposed to know, but oh no, they do. They absolutely do give it to you in the formula book. So 1 minus theta squared over 2. So that means that 2 alpha plus a half into 1 minus alpha squared over 2 equals 0. Yep. So we have 2 alpha plus a half minus a quarter alpha squared is 0. So 8 alpha plus 2 minus alpha squared, 0. So 0 equals alpha squared minus 8 alpha minus 2. That was so not going to factorize. But it's all right because it's 3 decimal places. So that means that alpha is minus b plus minus square root b squared minus 4ac all over 2a. And now this would give me... I can immediately discount the positive case, but I'll still go through the motions of finding what they are. So that would be 4 plus or minus 3 root 2. Now, the problem with 4 plus 3 root 2 is that is not small angle approximation. Small angle approximation is only valid for alphas around 0.1 or lower. So immediately, let's convert these into decimals, right? So in the positive case, that would be 8.24-ish. And in the negative case, it would be minus 0.24. So because alpha has to be small, that means alpha must be the minus 0.24 case. Am I done? Because this is the problem with if you're doing Edexcel. You can be convinced yourself you're done with the question just because you're done with the part. That I'm going to give is 3 decimal places. 2, 4, 3. Whoop. Okay. The point 0, 3 lies on C. Find the equation of the tangent to the curve. Well, let's first find what... So let me rewrite f dash of x. I think it was 2x plus a half cos x. Let me just confirm. And it's in radians, clearly. Okay, it doesn't really matter because it's 0.03. So when x equals 0, so f dash of 0 is 0 plus a half, so it's equal to a half. So that is the gradient of the tangent at the point where x equals 0. Which means that I can say that classic favorite, y minus y1. Can you guys also, can you just like do me a favor? Can you stop using y equals mx plus c? I really hate when people, like, it's such a pet peeve of mine as a teacher, but I'm like, that was the GCSE version and the A-level version is just so much cooler, so please use it. Because we have y minus 3 equals the gradient of a half into x minus 0. And then it just gets you like straight there in one go without you having to calculate a plus c separately. And it's just so much better. So y is equal to a half x plus 3. And it's just do me a favor. Do it for me and for you, but mostly for me. So we have a continuous curve. We have a table with the corresponding values of x and y for a graph of y equals f of x. We have a trapezium rule used with all the y variables in the table to find an approximate area between 3 and 4, and this area is 17.59. So we have to form an equation for a and b. This, I'm going to have to zoom out just so I have the values. But what this means is, and again, trapezium rule is one of those things that is in here in the formula book. Yeah, numerical methods, trapezium rule. So it's going to be that the area, so the integral, which is 17.59, is going to be equal to a half times the interval, which here is 0.2, into first y value plus last y value plus twice the middle values summed together. And this is an equation I can simplify without too much struggle. So this would be 0.1 into a plus 13.5 plus 2b plus 2 lots of all of these things summed together. This is not rocket science, so I don't need to show you the typing in phase of this. You add up all of the numbers inside the bracket, you multiply it by 2. So it's 2b plus 111.4. Should we multiply everything by 10? Yes, we should. So 175.9 is equal to a plus 2b plus 111.4 plus 13.5, which is 124.9. And then that means that a plus 2b is equal to 175.9 minus 124.9 is the 51 we were looking for. Perfection. So given also that the sum of all the y values in the table is 97, so this is just setting up simultaneous equations. So that means that 97.2 is equal to the sum of these y values. It's a plus 13.5 plus 16.8 plus b plus 20.2 plus 18.7. So we can say here that is a plus b plus 13.5 and 16.8 and 20.2 and 18.7, which is 69.2, which means, but moving that across to the other side, 97.2 minus 69.2 is 28. So a plus b is equal to 28. And then, hold on, is this a different part? This is a different part. So if I have these two equations now, I can clearly see that I can eliminate the a right off the bat. So if I do the bottom equation minus the top equation, a minus a is 0. Oh, you've never done trapezium rule. Oh, well, you've got a fun little last bit of learning to do. It's very late in the game to be learning new skills, but it's not too bad a skill. There's a formula, you apply it. So half, this h is the interval between these x values. So the interval here, the jumps in x are 0.2. So it's a half times 0.2. First y value plus last y value plus twice the sum of the middle values. And the reason why this works is because if you have a curve, that's not very curvy curve. So let me do a better one. What is it used for? It's used to approximate the area under a curve where you cannot do the integral analytically, meaning you cannot use your skills to find an exact integral. So if we have some sort of curve, nope, again, I really shouldn't pick an ugly curve. So I'll do a quick primer here. So if the curve is doing something like this, if we can't find the exact integral under the curve between here and here, what we can do is so we can kind of cut it into ribbons and approximate each ribbon as being a trapezium. So the area of a trapezium is a half, well, the average of the parallel sides times the distance in between. So it's a half times the distance in between times this plus this. And the area of this second one would be a half times the distance plus this times this. And you can see that each of these ones in the middle are going to get double counted. So you end up getting half times the distance in between, first plus last plus twice the middles. And that's basically summing up the areas of these trapeziums. It's an approximation if you cannot do the integral. The only thing you need to know in the syllabus is whether it will give an overestimate or an underestimate. In this case that I've drawn here, the line of the trapezium lies over the curve. So the area of the trapezium would be an overestimate. So this would give you an overestimate for the integral. So hopefully that makes sense as like a sort of conceptual idea. Now, so a minus a equals 0, 2b minus b equals b, 51 minus 28 is 23. So b is 23 and a is equal to 5. Great. How am I doing on time? I'm taking some detours, but it's fine. So question 6, logs. Oh, I love logs. Guys, I really like logs. Okay, so here, question A, if we have log to base 2 of root x, that is the same as log to base 2 of x to the half, which is the same as a half log to base 2 of x. So it's a half a. B, well, in fact, what I really should do, let me rewrite these lower down so I have them. A equals log base 2 of x, and b is log base 2 of x plus 8. Okay, so the second one, log base 2, and that I can write that as x into x plus 8. Using the log laws, that will separate out into log 2 of x plus log 2 x plus 8, which is very simply a plus b. And then for C, what sort of shenanigans are going on here? So log to base 2 of 8 plus 64 over x. How do I write that in terms of these? Well, I'm seeing, for instance, I could get an x plus 8. If I bring this all to one fraction, I would have 8x plus 64 over x. Now, I can see so that is log to base 2 of 8 over x into x plus 8. So I can see an x plus 8 here. Oh, okay, I can see what's going to happen now. So using my log laws, that is log to base 2 of 8 plus log to base 2 of x plus 8 minus log to base 2 of x. Log to base 2 of 8 is equal to 3, so it's 3 plus b minus a. So that was fun. Little tricky. Great. Log laws done. Question 7. Domain and function-y things. State the range of f. Well, let's look first at this domain. So we see the domain is limited to x is bigger than 2 because you can't take the square root of a negative number and have a real answer. So here, the minimum this thing can ever get is when x is equal to 0, x is equal to 2. This would be equal to 0. So every y value is bigger than 3, so that would be the range. So the range, it's f of x must be bigger than 3, and it can never be equal to 3 because x is never equal to 2. All right, find the inverse. Well, if f of x is equal to 3 plus the root of x minus 2, the way to find the inverse is to swap around the x and the y. So we will, instead of saying y equals this thing, we will say x equals 3 plus root of y minus 2, and then make y the subject of the formula. So x minus 3 is the square root of y minus 2. So I'll square, so x minus 6x plus 9 equals y minus 2, and x squared minus 6x plus 11 is equal to y. And that is the inverse. So therefore, the inverse function of x is going to be equal to x squared minus 6x plus 11. Great. So nice and calm, nothing too stressful just yet. We have a g of x. Find g of f of 6. Well, I'm going to write g of x here just so it's closer. So it's 15 over x minus 3. Okay, so g of f of 6. I'm going to first say f of 6 is going to be equal to 3 plus, now 6 minus 2 is 4, square root of that for 2, so it's going to be equal to 5. And so g of f of 6 is going to be equal to g of 5, which is going to be equal to 15 over 2. Nothing too bad. Find the exact value of the constant a for which things happen. Right, well, let's think about what happens. So what is f of a squared plus 2? I'll rewrite some things here. So f of x was equal to 3 plus the root of x minus 2, and g of x was equal to 15 over x minus 3, I believe. Yep. So what is f of a squared plus 2? Well, that is 3 plus the square root of a squared plus 2 minus 2. Cancels, so it's just 3 plus a. And so it's where that thing is equal to g of a. So therefore, a plus 3 is equal to g of a, which is 15 over a minus 3. Classic difference of two squares. A squared minus 9 is equal to 15. A squared is equal to 24. A is equal to plus or minus 2 root 6. Let's quickly check if there's any limitations on a. Well, x has to be bigger than 2. You can't put anything into the function that is less than 2. Although g of a, you could put into a, and it's a squared. But it does say value. It can't be equal to 3. Root 24. I'm going to stick with the idea that it should be the positive because of what you put into the function, but I'm not like 100% convinced. So I'll say, let's just say a has to be bigger than 2, which means that, and this is exam technique, right? It's saying a is value, not values, which very much incentivizes me to go in that direction. Okay. Oh, did I make a mistake? I don't think I made a mistake. 15 plus 9, 24. Unless I made a mistake with the 25 elsewhere. Am I doing something really silly? Well, I suppose it'll give me a chance to... I'll check that later. Oh, you mean... Oh, right. Okay, so it's not that I did something wrong. It's the question it had an unsatisfying solution, to which I say yes. But let's also do a bit more exam technique here. It said exact value. I'm not sure they would have used that language if the answer was a nice clean 5. I think they did that because they wanted me to not give a decimal to give it as the exact 2 root 6. So that again kind of tells me I went in the right direction using my exam technique. So here, ooh, hello. Here we have, for question 8, this is clearly going to be like a radians, arc lengthy, sector-y thing. So 2 congruent triangles joined to a sector that's 2.3 radians in the middle. We have an arc length. We have that as a strength of 15, which means that's going to split it into 7.5, 7.5. Oh, and this is also cool. So this, because it's congruent, these 2 angles in here are going to be the same. Let's just work on this for a bit. So these 2 angles are going to be the same. Now, the full thing would be pi. So it's going to be pi minus, well, I'm going to call them alpha for now, and then just remind myself that that is pi minus 2.3 all over 2 for each of those angles. Because I'm sure that's going to be relevant. Show that OC is 12. Well, that'll be done from the arc length. So we know for part A that arc length is r theta. So the arc length is 27.6. And that is equal to the radius OC that we are looking for times 2.3. So if we do 27.6 divided by 2.3, therefore r is equal to 12, which is OC, the radius of the circle. Great. Now for B, show that the size of angle AOB is 0.24. Well, that'll be simple enough. That'll be alpha is pi minus, what did I say it was? 2.3 all over 2. Which is, and again, nothing too complicated about typing that in, so you don't need to be over my shoulder here. 0.421, but that is not. Oh, it is. Brilliant. Okay. Come on, challenge me, paper. Bring it. Give me something nasty. Give me something where I have to think. I'm seeing a 6 mark, and I'm wondering if that's going to happen literally this very second. Given that the total length of the front of the stage is 35. B, C, D, E, F. Well, 35 minus 27.6 is 7.4. Divide that by 2, you get 3.7. So that's 3.7, that's 3.7. And we said those were 12, didn't we? I'll put that working in. So 35 minus 20. And now I'm satisfied I know what I'm doing, but I just want to put it down to show where these numbers came from. Find the total area of the stage. Ooh, okay. So what we're going to do is we're going to find the area of the triangle by doing half AB sine C. We're going to double that up because we have 2 triangles, and then we're going to find the area of the sector using a half r squared theta. So here, I'm going to say that the area of the triangle is a half times, I think it was 3.5, 7.5, half A times B, which is 15.7, half AB sine of the 0.421. So a half of that times sine of, well, got to make sure I am in degrees, radians even. Probably should have shown you this. I'll show it in the checking. Is 24.06 for each of the triangles. Area of the sector is a half r squared theta. I think it was 2.7. 2.3. So 1/2 times 12 squared times 2.3 is 165.6, which means the total area is 165.6 plus twice the 24.06. Plus twice the 24.06 gives me 214 meters squared to the nearest meter squared. Okay, nothing too bad. First 3 terms of a geometric series. This is a classic. This is a classic. This comes up all the time. It's one of my absolute favorites to demonstrate. So the way you got to think about this is to think that to get from one term of a geometric series to the next, you have to multiply by r. That means that one term divided by the previous term gives you r. So in this case, it means that 12 minus 3k. In fact, let me zoom out just so I can write this down. So 12 minus 3k over 3k plus 4 is equal to k over 16 all over 12 minus 3k. And that's because both of those things are equal to r. So then I can form a quadratic equation from this by cross-multiplying. So 9k squared minus 72k plus 144, from multiplying this by this, equals 3k squared for plus 52k plus 64. Then bringing that across to the left-hand side, 6k squared minus 124k plus 80 equals 0, which means that 3k squared minus 62k plus 40 equals 0. Let's test my mental math, because it's a show that, so I took some liberties, and I was correct. Good, good, good. Now, obviously, you can take your time. Take as many steps as you want to like expand out those brackets, but I was feeling confident. So then, given that the series converges, now that matters because that means that the magnitude of r must be less than 1. That's the helpful hint there. And I can immediately tell that this is going to give me 2 values of k, and I'll have to eliminate one on that basis. So let's solve this quadratic for b part 1. So 120, yeah, 120 is, so it's going to be minus 60 minus 2. So the 60 is going to be formed from the 3k and minus 20, and then I've got a minus 2 there. So that was done by inspection. You could use either of the previous methods, but I like to show some range in case you have a particular method you like. So this was by inspection. I could have done what I did before and said, I called it 3. I could have called that, so 120, I could have called it minus 60 and then 3k minus 2 all over 3, where the 3 would cancel with this to form the k minus 20. Or I could have written it as a 3k squared minus 60k minus 2k plus 40, and taken a 3k and a k minus 20, minus 2 into k minus 20, and then factor it out like accordingly. So you've got a huge number of ways of doing this. When there's a number in front of the k squared or x squared, you pick your favorite. So k is equal to 2/3 or k is equal to 20. But if k is equal to 20, well, let's think about it. Well, r, the common ratio r is 12 minus 3k all over 3k plus 4. So what we're going to have to do is to check both of those k's. So it seems like it wants the k to be the small one, but maybe not for what they've given us, right? So when k is equal to 2/3, r would be equal to 12 minus 2 all over 2 plus 4, which is 10 over 6, which is too big. Sneaky, sneaky. That's the 5 over 3. So we're going to have to take the k equals 20 case. And when k equals 20, r is equal to 12 minus 60 all over 60 plus 4, which is minus 48 all over 64, which is minus 3/4 if I'm not mistaken. And I am not mistaken. And that is the value of r, which means that k is equal to 20. So because I'll say the magnitude of r has to be less than 1, that means that k equals 20 is the answer. So then, given that k equals 20 is the answer, find the value of the sum to infinity. Well, we know the value of r. We just need to find the value of a, which is 3k plus 4. So was that B? Yeah, it's B part 2. So it's 3k plus 4, where k is equal to 20. So a is equal to 64. So the sum to infinity is 64 over 1 minus r. So it's 1 plus 3/4, which is 64 all over 7 over 4, which is 64 times 4 all over 7, which is 256 over 7. And that is the sum to infinity. Great. Question 10. So we have a circle equation. All right, so what we have to do is to complete the square in x and y to get it into the form of a circle. So here for a, let's write it out again. So x squared plus y squared plus 6kx minus 2ky plus 7 equals 0. So we have x plus 3k all squared. Oh, no, God, don't move on yet. All right, so because I got to subtract off this thing squared, which is 9k squared. And then I've got y squared, nope, y minus k all squared minus that thing squared, which is k squared, plus 7 equals 0. So that means that x plus 3k all squared plus y minus k all squared equals 10k squared minus 7 by moving those guys over to the other side. So this means that the center has coordinates minus 3k and k, and the radius is the square root of 10k squared minus 7. Please don't forget that square root. So for B, the line intersects the circle at 2 distinct points. This is a fairly standard thing where you just substitute that into the equation, which would give you a quadratic in x. And because it intersects at 2 distinct points, you immediately know that that quadratic will have a discriminant that is bigger than 0. That's exactly what we're going to do. So now that we've got it in this form, we're going to say y is equal to 2x minus 1. So that means that x plus, in fact, no, let me substitute it into the already expanded out form. So I'm going to say x squared plus y squared plus 6kx minus 2ky plus 7 equals 0. And we're going to expand this all out. So x squared plus 4x squared minus 4x plus 1 plus 6kx minus 4kx plus 2k plus 7 equals 0, making sure I don't make any execution errors. So 5x squared. Now let's lump together all the x's here. Yeah, honestly, there's people watch some weird stuff. So like I used to be adamantly, there's this channel called Crap King the Cryptic, which is all about like outrageous Sudokus. And I had such a phase where I was going through every single one of their videos. And they're also wildly entertaining. There's just something about people doing things, like actually trying to do a thing, which is weirdly compelling. So yeah, no, very happy to have you. It's people need hobbies, and the weirder the better. Very happy to have you. So the x squared, so you got your 5x squared here. The 6kx will combine with the 4kx to, so that once you subtract that off, that'll be 2kx. So what's happening with the x's? There's 2k. Oh, no. Wait, no, that's right. So 2kx minus 4x. So I can take the x out and it's that. And then I've got 2k plus 8 there equaling 0. Great. So we know that this discriminant is going to be bigger than 0 because it has 2 distinct solutions. So b squared minus 4 4ac is bigger than 0. So 4k squared minus 16k plus 16 minus 40k. What's this going to be? Let's take a 2 from that. So this minus 160. I will confirm that on the calculator, though, because there's no point. You don't get bonus points for doing it in your head. So you just got to get it right. So we got 4k squared minus 56k. 16 minus 144 must be bigger than 0. I think this all divides by 4. So 56 divided by 4 is 14. And 144 divided by 4 is 36. So with a quadratic inequality, you have to sketch it, which means first you have to factorize it. This does not seem to want to factorize, which upsets me in a very personal way. Do not enjoy. Please just factorize. Why can't we just have quadratics that factorize? Is that too much to ask? Is it too much to ask? Did I expand this out correctly? 4x squared minus 4x plus 1. Yes. 6k, 2k, and that y is x, 2x minus 1. Cool. Plus 7. Cool. This is all correct. Cool. Did I make a mistake after that? So that is my 5x squared. Cool. Minus 4x's and plus 2kx's. Cool. That's a... No, this looks good. So b squared minus 4ac is bigger than 0. 4k squared minus 16k plus 16. That works. So I should be left, in fact, with k squared minus 4k plus 4. Yeah, this works. This does work. No, but it does. It's a literal personal attack. Like when things aren't correct, I get upset, and I think that is my prerogative. So here, we're gonna have to sketch this. Just factorize. This day. Okay, so we're gonna have to solve for this. K is equal to minus b plus or minus b squared. Don't just. Why can't the numbers just be pretty? 4ac plus 144 all over 2a. Sorry, I've gone full whiny mode. That's just, no one wants that. Patrick, get it together. Hold on a minute. So 14 plus square root 196 plus 144 all over 2 is 7 plus or minus root 85. Blah. All right, so boom, graph. This would be 7 minus root 85. This would be 7 plus root 85. We want this thing to be bigger than 0. So that happens on this branch and this branch. So we need k to be less than 7 minus root 85, or we need k to be bigger than 7 plus root 85. You see that? You see non-calculator? There you go. You want nice, pretty... These. Why can't more papers be like that paper? Right. Well, this is all the possible ranges of x. I'm looking for like I want questions that like challenge you conceptually but aren't annoying. Like I really like the sort of like the trig identity questions where you do like 10,000 steps and then it just simplifies to 1. Like I like those kinds of questions. I don't like it when the. All right. Question 11. So this is logarithmic modeling, where I can immediately tell you we're just going to take logs of both sides of this equation. We're going to compare it with the gradient and the intercept to find the values of a and b. Because that's how it always goes. Now here, when t equals 0, b to the 0 is equal to 1, so v will just be equal to a. So when t equals 0, how am I going to do this? Let's write this out. Apologies, it's a little zoomed out for you guys. So v is equal to ab to the t. And we know that when t equals 0, that log to base 10 of v is equal to 3. Log 10 v equals 3, so v is equal to 1,000. So a is equal to 1,000. by plugging that in. Or to do it the long way, 1000 is equal to a b to the 0, which is just equal to a. So about 1000 is equal to a. It's the initial value. So b, what we're going to do is we're going to take log to base 10 of both sides of this. So log v is equal to log of ab to the t, which is equal to log a plus t log b. Now, on a graph of log v against t, that means that the gradient will be log b and the intercept will be log a. As we've established, log a is 3, which means that a is 1000. So now we need to find the initial value, yeah. So as we've established, log a is equal to 3, which means that a is equal to 1000. Oh, so in fact, this is all they wanted. They didn't even want the a equals 1000. They wanted that in b. Cool. Well, I've belt and braces that. Now let's find the gradient from here. So the gradient, I'll just do it here. The gradient is 2.79 minus 3 all over 10. I'm not going to be a hero. Let's just type this straight in. 2.79 minus 3 all over 10 is minus 0.021. So that means that log base 10 of b is minus 0.021. So b is equal to 10 to that power. So 10 to the answer is 0.953. Now, let's see how they wanted it quoted. 3 sig figs. So that means that v is equal to 1000 times 0.953 to the t, which is what they wanted. Reread the question. They wanted v in terms of t. So exactly 2 years after it was bought, the value was 2 years. How is t defined? T is defined as months. So 2 years later, t is equal to 24. Because that's one thing with these modeling questions. Always look at the units. So when t is 24, v is 1000 times 0.953 to the 24. So 1000 times 0.953 to the 24 is 314.94. Because it's money, so I'm going to leave it like that. This is close to close to 320. So the model is reliable, is what I'm going to say. Because the model, it comes close to the actual reality. Okay, so that's question 11. Question 12. Ooh, first principles with sine. Oh, thank you. Okay, we haven't said, okay, we're getting some actual fun now. So here, we are going to say that dy dx is, and I'm going to write this out in full, guys. I'm going to do this properties. The limit as h tends to 0 of sine of x plus h minus sine of x all over h. So if you need a primer on first principles, we know the graph of sine x to something like this. We're going to take a point x, and we're going to take a point that's just a little bit further on. So point A and point B. We know the coordinates of A would be x and sine x, and we know the coordinates of B would be x plus h and sine of x plus h. And you just take the linear gradient. So it's the second y minus the initial y all over the second x minus the first x. So x plus h minus x, the x's cancel, and you get this. And then we take the limit as h tends to 0. So what we're going to have to do here is use the addition formula on the sine x plus h, which is in your formula book. Yeah, just here. There we go. So that will be sine x cos h. So sine cos plus cos x sine h Yep. Minus sine x all over h. So that is, if I rewrite that, that is the limit as h tends to 0 of. It will be sine x times cos h all over h plus cos x into sine h all over h minus sine x over h. Apologies. That was not the correct way to group that. Take two. What I should have done is to take out, find the sine cos and the sine part and the cos part separately. So that's sine x into cos h minus 1 all over h plus cos x into sine h all over h. And then would you look at that? That is in the form that is required. So this bit goes to 0. And the second bit goes to 1. And so that is just equal to cos x. Would you recommend using Edexcel resources even if you do AQA math? There are barely any resources for AQA math? Yes, I would definitely, because at a certain point, math is math, right? You want to be saving your past papers for closer to the real thing. And so you can use things from other boards to train your skills up as long as you know what the differences are between the boards. So for instance, your large data set will be different from Edexcel's large data set. So anything to do with the weather data is maybe something you can afford to skip when doing it. But yeah, I would honestly, math is math. I cross boards all the time. I use stuff from IB, I use stuff from OCR, from Edexcel. A good question is a good question. Don't discriminate. Cool, so 13. Wait, did I finish? Yes, I did. Okay, so question 13. On a roller coaster ride, passengers travel in carriages around a track. The carriages complete multiple circuits such that maximum vertical height is 60. It starts from 2. The ground is horizontal. So we're modeling it with a quadratic, which is the world's worst roller coaster. Well, I suppose it's just the first loop. Okay, whatever. Find a complete equation for the model. Okay. Well, this isn't completed the square form already, so we know the maximum height will be when t equals 20, and the maximum height will be a. So the vertical height above the ground is 60, so that means that a is 60. Oh my God, yeah, this is too much. I'm not scrolling around. Okay, so we know, I'm just going to show you that's the rationale, right? When t equals 20, h equals a, which is the maximum, or rather, you can sketch this, right? So this will be, so this maximum height should be at 20. That should be 60 above the ground, and it should start from 2 above the ground. So that means, and when t equals 20, that is equal to 0. So a is equal to 60. And when t equals 0, we're going to plug in that h is equal to 2. So 2 is equal to 60 minus b into minus 20 squared is 400. And from that, we can work out what b is. So 400b is equal to 58, and b is equal to 58 over 400, which is 0.145. Now, I am going to write this down now here. So a as above. Just so I'm going to write that just so I know that it is there. So here h is equal to 60 plus, minus. Nope, that is not what I wanted to click. So 60 minus 0.145 into t minus 20 all squared. Great. So determine the height of the carriage above the ground when t equals 40. When t equals 40, it's going to be 2. Just from symmetry, it's going to be 2, but let's humor them, right? So that is going to be 20 squared. And would you look right the way at that? That is, I literally, this is the problem, as I can talk faster than I can type. Well, would you look at that? It's the 2 meters, which we knew it was going to be by symmetry. Oh, sorry, Edward, I didn't see that you put a follow-up. Would you recommend doing full papers then, or just questions? I would do questions to warm up the skills. Depending on how many past papers AQA has, I might save them till later. You could also do the papers of different boards if you want to practice your exam technique, including how to check your work. But also, just do everything. Get your hands on everything. Like all. There's plenty of time between now and the papers, but it's time to get going, I think. So here, in an alternative model, we're modeling it as trig. So now we want to use the exact same information as before to find alpha and beta. Well, let's talk about where this 29 comes from. This 29 comes from the fact, well, if we plot this, 29 is the amplitude of 29. So the difference between the maximum point and the minimum point is 58, which is what we have. It goes between 2 at the bottom and 60 at the top. So it's going to be, well, beta is just 2. Full stop, the end. Because when I tell a complete lie. Okay, let's work on this proper. So h is equal to 58 cos, no, 29 cos. 29 cos of 90 plus alpha. I don't know why the 9 is there, but whatever. Just roll with it. Plus beta. What we know is that when cos of 90 plus alpha equals minus 1, h equals 2. So therefore, because that's the minimum height, and therefore 2 is equal to minus 29 plus beta, so beta is equal to 31. Great, so we have that. Now, it starts there. It starts at 2. So it starts with this case being true. So we know that cos of 90 plus alpha does in fact equal minus 1 when t equals 0. So that means that cos of alpha equals minus 1. And therefore, is this in degrees or radians? It's in degrees, which means that alpha must be equal to 180 degrees from the cos graph. So that means that h is equal to 29 cos of 9t plus 180 plus 31. Okay, so that's the model. Given that the carriages move continuously for 2 minutes. So if it moves continuously for 2 minutes, that means that the time goes up to 120. So the first model would give a value of Oh, what was it? It was 60 minus 0.145, because I have a weird memory for numbers, times 120 minus 20 all squared. God, I really do have a weird memory for numbers. How did I remember that? Damn, that worked. All right. And that would be equal to, I'm guessing it's going to be through the floor. Well, would you look at that? Oh, it's not even through the floor. It's a kilometer underground, guys. Love that for me. Not physical. Whereas for H2, we would get that the height is equal to 29. This really is not too much of a bad paper, is it? So 9 into 120 plus 180 plus 31. And that would be equal to, so let's put in 120 equals 29. Now let's go back 2 degrees. Oh, I never bothered. I burned through the battery on this thing, genuinely. And like, this was brand new in the summer when I was revamping all my tech, and it's like already gone, completely shot. All right, so 29 cos 9 answer plus 180 plus 31, and that is equal to 2. So it's at the minimum. So yeah, it never goes underground. Sweet. 13. Come on, have a fun question. Ooh, okay. Yay, proof. Wait, it's a proof for all n. Okay, I like. So proof for all n. This is going to be proof by exhaustion, where we split the n's into different categories and exhaust that category. So first thing we're going to do is binomially expand this, and we're going to get n cubed plus 3n squared plus 3n plus 1 minus n cubed. So it's going to be 3n squared plus 3n plus 1. Now, what we're going to do is to split this into even and odd. So when n is even, so when n is equal to 2k, then this thing is going to be 3 into 2k all squared plus 3 into 2k plus 1. So that's going to be 12k squared plus 6k plus 1, which is 2 into 6k squared plus 3k plus 1. So it is 2 times an integer plus 1, therefore odd. And when n is odd, which means that n is equal to 2k plus 1, this time we're going to have 3n squared plus 3n plus 1 equaling 3 into 4k squared plus 4k plus 1 plus 6k plus 3 plus 1, which is 12k squared plus 12k plus 3 plus 6k plus 4. So it's 12k squared plus 18k plus 7, which I can again make that 2 into 6k squared plus 9k plus, in fact, I'm going to split that out. So that plus 7, I'm going to call that plus 6 plus 1. So I'm going to make that bracket in here, 6k squared plus 9k plus 3 plus 1. So again, it's 2 bracket plus 1, therefore odd. So given that every number is either even or odd, it doesn't matter. This thing is always odd at the end. Therefore, I'll just write the concluding statement. Therefore, this thing minus this thing, odd for all n. Given that all n are either even or odd. Tell me that wasn't the last question. Woo! Oh, yeah, here we go! We're having fun! Oh, yay! That looks so ugly! I've been waiting all paper for something like this. Oh, man, this has just got me in a right good mood. I need to sort out my priorities. But, like, guys, this is, why are we, okay. Because, like, in the real thing, you want a nice, fun paper, right? But do you, though? Because if you have a fun, like a question which just, like, separates people, then you're like, oh, okay, I'm prepped, I'm ready to go. I can prove myself this is going to separate people. And so if I make a little execution error, it's not going to affect my game. You want to ride high on the curve. So you want good, hard questions. This, yes. Also, I don't have the pressure of the real thing. So a difficult question is the only thing that gets me going anymore. So this, woo! Guys, Difficult questions shouldn't do this to me. Why am I like this? Ugh. Okay. Okay. I've had my moment. I've had my moment. Oh man. Okay. Oh, it looks so good. Guys, this question. Look how ugly this question is. That's atrocious. What is this? Yo, what? Oh man, I was waiting for it. All paper. I was like, when's it gonna come? Here we are. Okay. I'm gonna make sure I get to the end and I don't forget to do a part of a question. Okay. Okay, so we're just doing this now. This is a thing that's happening now on this day. I'm not even worried about the fact that I got 48 minutes left. That's plenty of time to check. Right. Let's get into it. So f of x was equal to, oh man. 7x e to the x. All over the square root of e to the 3x minus 2. Although me having reactions like that to math shows I'm in a good profession. This is where I'm supposed to be. So we got to get the derivative now. So this is quotient rule. Let's go. So derivative of that. Oh man, this is so ugly. This is gross. Because how are you going to differentiate this? Well, that's going to be by the chain rule. This is so bad. So it's bottom d top, bottom d top. Now, how do we differentiate this? Product rule, first d second plus second d first. So it's bottom d top. So first d second plus second d first. So that's bottom d top minus top d bottom. Now, how are we differentiating this? D big. So it would be a half into e to the 3x minus 2 to the minus a half, because that was the half. And all of that times the differential of the bit in the middle, which is 3e to the 3x. So that's bottom d top minus top d bottom all over bottom squared. Okay, just a nice normal first step on a question. Just like totally fine. So we're gonna get an 3 over now. Okay, I know what's gonna happen next. With any sort of quotient-y, rule-y, product-y, rule-y nonsense, this thing, you'll see that's here in two different powers, which differ by 1. In that case, take out the one with the lesser power. So that would be e 3x minus 2 to the minus a half all over e to the 3x minus 2 into. Now this guy, once I take this guy out, I'll be left with an e to the 3x minus 2 left behind. I am so giving this question to students when I want to punish them. Oh, this put me in such a good mood. So that's minus 7x e to the x times a half times a 3e to the 3x. Okay. So far, so good. So this is where we're going to get our over e to the 3x minus 2 to the 3 over 2. So I've got the bottom. That's where that's coming from. And I've got my half as well. So I can take... so let's take a half out. So it's 1 over 2 into e to the 3x minus 2 to the 3 over 2. So I've taken a half out of here, but this didn't have a half. So I have to put a half in by multiplying it by 2. No, this question has made my damn morning. I am so happy with this. I have never... why did they stack the difficulty like this? Okay. Cool. So I've got that far. So I've got the denominator on lock. Boom, smashed it. Now it looks like I'm taking a 7e to the x out. So let's make that happen. 7e to the x all over 2 into e to the 3x minus 2 to the 3 over 2. What have I got left when I do that? Well, I can take a 7e to the x out of both of that. So I'm left with 2 into e to the 3x minus 2 into x e to the x, nope, that e to the x has come out, into x plus 1 minus x into 3e to the 3x. Cool. Because that's the thing. When the questions aren't giving you any resistance, you kind of know something like this is waiting for you at the end. Cool. So I can take an e to the 3x out somewhere, wherever it is. Do I just... So there's an exponentially bit, and then there's a linear, there's just a quantum thingy bit. All right, so let me expand out that bracket and sort of see what happens. E to the x all over 2. Now, let's also talk about what you would do if you couldn't do this. No worries. Oh, hang on a minute. Am I going to have to pay attention? Don't make me pay attention. All right, so I'm going to just be nice and methodical here. So that's 2 into x e to the 3x plus e to the 3x minus 2x minus 2 minus 3x e to the 3x. Cool. 7e to the x. God, this is getting annoying having to write this all out, but no, do you know what? It's worth it because it's so rare you get a question this ugly and get the satisfaction of toppling it. Plus 2e to the 3x minus 4x minus 4 minus 3x e to the 3x. Cool. So 7e to the... Let's keep it going, guys. We're getting there. It is folding under the weight of our effort. So that will cancel down. So we have e to the 3x into 2 minus x minus 4x minus 4. Is that it? Oh, smashed it. Absolutely smashed it. Oh, that felt good. That's right? No, I overshot the mark. Woo! We did part A out of part 3. Yeah. Okay, so guys, okay, let's look. Let me remind you what the skills there were. So you, first of all, you just do it. You got to know your quotient rule. I know, right? You got to know your quotient rule. You got to know your product rule. You got to know your chain rule. And then you got to know that it's very common for you to see these things with like the power difference of 1. You take the one with a smaller power out as a common factor, and then you're left with that factor left to the power of 1 left. And then you just keep going back to the question. You just peel off factors in the form that they have it until you're left with what they want. Now, even if you couldn't get that, you could just jettison those 5. Well, try and get it some way into the question to pick up method marks, jettison it. Oh, no, you actually have to solve it because they don't give it to you. They don't show you with the A and B. You have to find the A and B. So if you don't do that, you're messed up with the whole rest of it. But then, okay, so what you would have to do with the rest of it is you would have to do it just with the A and the B and you get the error carried forward. Oh, man. Nah. Okay, so now we got to solve for this nonsense equaling 0. So 0 equals stuff. So this stuff can never equal 0. Exponential can never equal 0. So therefore, e to the 3x into 2 minus x minus 4x minus 4 equals 0. And we have to rearrange this for x. We have to make x the subject. So 2e to the 3x minus x e to the 3x minus 4x minus 4 equals 0. So let's move the x's to the other side. 2e to the 3x minus 4 is x e to the 3x plus 4x. So you can take an x out, e to the 3x plus 4, and we get that x is equal to 2e to the 3x minus 4 all over e to the 3x plus 4. Is that what they wanted? Yes. Now, by the way, cheeky, what you could have done, guys, if you were stuck, is you could have reverse engineered this. By knowing that this thing equals 0 when x equals this thing, you could have rearranged this thing and snuck it back into this form and reverse engineered what A and B must be without even doing part A. So here you could have said, oh, let's rearrange this. almost like reverse engineering it on paper, you could have said, oh, okay, something's gone wrong. I don't trust myself. Plus 4x equals 2e to the 3x minus 4. And you could have rearranged this. So then you could have said, I'm seeing a minus x, so I need to move this all over to the right-hand side. So this equals 2e to the 3x minus xe to the 3x minus 4x minus 4. And then you could have said, all right, e to the 3x into 2 minus x minus 4x minus 4. Oh, look, ding, ding, ding. That's this exact form. A must be equal to minus 4. B must be equal to minus 4. So exam technique, right? Cheat, reverse engineer it. That can sometimes save your life if something's gone horribly wrong. Given that the A and the B were not given to you and you needed them moving forward, the next show that you could have reverse engineered it, got that, used it, and then pretended like you got it the whole time, and then like work forward. So that can sometimes save your life. So never give up. See if you can think of a way to get there. So now we got this thing. It's got 2 positive roots. We've got an iterative formula, which is absolute chaos. You can just tell, man, I've gotten so much more energized now. I was like, guys, I'm just going through the motions. Now I'm like alive. I need to calm down. Like, this is too much. Like, what am I doing? This is okay. So we have our iterative formula. Diagram 1 shows a plot of part of the curve with this equation and part of the line with equation y equals x. Draw a staircase diagram starting with x equals 1. Now, this is nice and simple. So where are we starting? This is, so on 42 diagram 1, we're starting with x equals 1 to find beta. Okay, there's a mantra here, vertical to curve, horizontal to line, and just do it. So I can't draw perfectly straight lines on this, but whatever. You would do this with a ruler. So vertical to curve, horizontal to line, vertical to curve, horizontal to line, vertical to curve, horizontal to line. And you can see it's approaching beta, doing at least 3 steps. Great. Use the iterative formula with x equals 1 to find to 3 decimal places, x2, and then beta. Find to 3 decimal places the value of beta, so that's when it agrees. This is where I am actually going to take the calculator out and show you guys what's going on. So here, we're going to start with x equals 1. So I'm just going to type 1 equals. Then I'm going to type in 2e to the 3 answer all minus 4 over e to the 3 answer plus 4. So here, let me scroll down. Did I need to show? Only use a copy if you need to redraw your answer. Okay, cool. I don't need to redraw. So for part D, 1, we needed to find the value of x2, which was, is it gonna, no. Oh, this wasn't an issue before because I had it. Okay. Well, you see it. So I'm just going to copy down what the number is. So 1.502 is 3 decimal places, which is what they wanted to. So we want the value of beta now. So we're just going to keep going. So I'm going to show you what I would do. I would be writing these numbers on the way. I would be writing x3. So I'm just going to keep. So this is x3. This is x4. This is x. So 957. 967. That's also 967. So I have 2 that agree to 3 decimal places. So I'm going to stop there. So 1.967 to 3 decimal places. And you can confirm it to yourself by keep going. Oh, that's gone over 966 and 968. Oh, guys, no, it is 968. No. Okay, so that's good. I kept going then. So it is 1.968. You just keep going, and eventually it converges on a value. And you just, so you can convince yourself. And then this is the final to that many decimal places, right? Okay, so that's your beta. And then finally, using a suitable interval at a suitable function that should be stated, show that alpha is that. So alpha is a solution to what? Well, this equation has two positive roots. Alpha and beta. And these are the x-coordinates of the turning points. So I think I should be plugging this into f dash of x and showing that there's a sign change. I think. Or I can plug it into... No, if this has two positive roots, maybe I plug it into here and get a sign change. I'm going to try this first because that looks less disgusting. So what am I meant to show? Hold on, let's just plug it in. So 432. 0.432. Let's 432 equals, and then 2. So we have to, what we're going to have to do is therefore try, that's not what we should try. So suitable interval. So we're going to have to try 0.4315, which is the lower bound. You could even remember to put it in decimal. Could you imagine remembering that? 0.4315. So you can put that in first. Let's see if we get our sign change. So 2e to the 3 answer minus 4 all over e to the 3 answer plus 4 gives you 0. Oh, no, of course. No, that won't work because it should converge on the value. Because you notice how that's very close to the 0.432. Okay, so we're not going to do that. We are going to put it 0.4315. It should go into, I think, the f dash of x. Oh, man. No, I'm going to put, do you know what? I'm just going to put it into this bracketed form because we know these bits are always going to be positive, and we know if it's in that interval, there needs to be a sign change. So if there's going to be a sign change, it can only come from, yeah, I paid for the emulator. Or rather, I didn't pay for the emulator. I'm on a 3-month free trial, but then I will end up paying for the emulator. So I'm going to plug it into this guy. So e to the 3 answer into 2 minus answer, it was minus 4 answer minus 4. Great. So this guy, no. Okay, well, there's the answer. I'm going to write down what the answer is. Minus 0.0023. When I plug in the first bit. Now the upper bound on that is 0.4325. So on this, I'm going to do the same thing. E to the 3 answer into 2 minus answer minus 4 answer minus 4. And you get the answer, which is 0.0073. Change of sign in the interval. Therefore, change of sign in the interval. Therefore, there is a solution between 0.4315 and 0.4325. Therefore, 0.432 is correct to 3 decimal places. Boom. Take that, question 15. God damn it. All right, that took up like a decent chunk of time. I still got half an hour to check. Guys, we're chilling. We are cool. Question fit. I honestly, the people, because I've not seen that question. I've never seen that question, never seen that paper. That was a complete blind solve. So all the people who knew that was coming, there was some delicious, like, oh, he's gonna get it. Oh, he's gonna get it. Put me in such a damn good mood, though. So here, nothing to really be done for it, apart from maybe just check things on a calculator, make sure you didn't do anything silly. Oh, nope, did a thing. Shouldn't have done a thing. I made it teeny tiny. How do I make it un-teeny tiny? My tech is well, okay, let's be clear. It's not the tech that's teching, it's me that's anti-teching. So that is 2/3 x to the 3 over 2 minus 5/3 x to the half. Raise that to 5 over 2. Let me just make sure that I'm going to use a button I never, ever, 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 ever use. I hate the divide button because I want it to be fractions, but I'm not going to do like fractions on fractions on fractions. That'll just get real ugly real quick. 4 over 15 is correct. 5/3 divided by 3 over 2. Yep, 10 over 9. And I didn't forget my plus c. Remember, limits or plus c, or you will be limited to a c. Plus c, desperately important. So here, show that. I did show that, hence find the value of a. What I'm going to do is plug in my value of a. So if a is 3/4, and if I plug that into here, I'm going to get answer into 4, answer squared, plus 5, answer minus 6, and get 0. Great, that is a correct answer. Use algebra to find the exact solutions of this thing equaling 3. Well, I'm just going to type them in. So, also, if that is true, if a is 3/4, then 3/4 of 4 is 3. So I'll make that a plus 3. So I'll type in minus 5 plus root. No, what am I doing? Guys, this is bad checking technique. On an Edexcel paper, the first, no, I've fallen for this before. First thing you do is check to make sure you've answered every part of every question. Come on, Patrick, think. Do you have an answer to A? Yes. B part 1 and 2. Yes. 3A, yes. 3B, yes. 4A, 4B, yes, done. 5A, 5B, yes, done. 6A, B, C, yes, done. 7A, B, C, D, yes. I didn't label it explicitly, but yes. Done, good. I won't, because I'll tell, while I'm doing this, I'll tell you the story. So I had a mechanics paper once, and I can't remember if it was year 12 or year 13. I went through this. I started checking. I was like, guys, I bossed that paper. Oh, I'm checking it. Oh, I did so well. This is going so well. And then with like 2 minutes left, I see that I accidentally missed a part D on a question, which was repeat the entire question for 7 marks, and I didn't have the time to do it. And if I just checked first, I would have gotten full marks on that paper. I'm still mad about it. So A, B, C, check, done. A, B1, B2, good. Yeah. 11, A, B, C, good. 12 is just one part. I did it. A, B, C, D, good. 14, you just do it. And 15, A, B, C, D1, 2E, A, B, C, D1, 2 is beta. Yeah, and E I did above. Great. Okay, so every part of every question, done. Could I do some AQA papers? Okay, yeah, fair enough. I haven't done an AQA paper. I should see that. You've probably got some skanky data set, though. I don't like it. Yeah, I'll do some AQA papers. That's only fair. I did some Edexcel. I did some OCR. I've not yet done. I'm going back through Edexcel. I may as well do some AQA as well, just to make sure everyone's nice and covered. So here, what I would do is I would plug this value back in. So 5 plus root 185 all over 8. So checking that by putting it back in. F of x, so 4 answer cubed plus 5 answers squared minus 10 answer plus 3 is 3. Smashed it. And I will check the other one, even though I really don't have to, because if the plus works, then I know the minus will work. But I'm not going to risk my A level on it. So we're just going to plug it back in. 4. Oh, sorry. Let me just make it a bit bigger for you. Boop. Wait, does your school not do AQA for normal math, but it's doing AQA for further math? Your message has been retracted, sir. Interesting. So 4 answer cubed plus 5 answer squared minus 10 answer plus 3. Oh, you wish they did these, right? Yeah. So this equals 3 as well. Great. So that was good. I've put those in. I've checked these. These are correct. Show that. I did show that. Find the smallest value of A for which that is true. I'm just going to try plugging in. So the smallest value of A is 5. So I'll try 4 and I'll try 5. So for 4, why would you mix boards? No. So OB, let's plug in 4, let's plug in 5. So the root of 2 squared and 4 squared and 5 squared. I'm plugging that in. That's root 45, which is bigger than root 38. So that is definitely true. No, 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 no. Oh, no, no, no. Oh, no. Guys, why am I so bad at buttons? Okay, the answer is I don't practice. All right, I don't need to rub it in my face. Like, I know, and that would be root 36, which is less. So given that A is a positive integer, yes, the minimum is 5. Good, that is checked. Question 3, marked safe. Use the small angle approximation to estimate the value of theta to 3 decimal places. What I'm going to do is plug that in. So I'm going to plug in minus 0.243 equals. I'm going to check that my thing is in radians. And then I'm going to say 2 answer plus a half cos answer close bracket is something very close to 0. So that seems good to me. Then here, so we have this point, we have this differential, plug in x equals 0. You're going to get a half. So that is a half. That goes through 0, 3. I'm happy with that. Trapezium rule. This was a show that. And let me just check again. You don't need to see me press these buttons, but 16.8 plus 20.2 plus 18.7 plus 13.5 does equal 69.2. And then 97.2 minus answer does equal 28. So I have my simultaneous equation. I'll just plug the numbers back in and check to make sure they work. 5 plus 23, 28. 5 plus 2 lots of 23, 51. Great. So I'm plugging these back in. These look okay. So this is just, I got it right. Full stop, the end. No notes. Power law. So bringing the power out the front, half A. This is A plus B. This, I just really enjoyed how I did that. So bring it to a common fraction, common denominator. Take out an 8 over x. So that's log 8 plus b minus a, 3 minus a. Yeah, I like. So here, state the range. It's bigger than 3. Find the inverse. Swap around the x and y. X minus 3. You square it. You add 2. That works. Find g of f. Okay, so what I'm going to do is so f of 6. So I'm just going to do 6 equals 3 plus root answer minus 2. And then say 15 over answer minus 3. Of course, I syntaxed it. 15 over answer minus 3 is 15 over 2, which is what I said. Find the exact value of the constant a for which this is true. So I've said that a is root 2 root 6. Now, if that is true, let's do f of so this is f of answer squared plus 2 minus answer. So that is f of thingy. And I'm going to subtract from this thing, g of thingy, and I should get a cool 0. Bam. So I got the right answer. Okay. Got 18 minutes left. Let's check 8. Show that OC is 12. I did that. Show that that is that. I did that. Find the area. So I found the individual angles, and that was 12. That was the angle. That was 35 minus 27.6 divided by 2 is 3.7. So that is 3.7. So 3.7 plus 12. I'm still in radians. So half A B sine C does give me my 24.06 for each triangle. Times that by 2. Add that to a half r squared theta. And it is 214. So I feel good about that. Geometric series, show that it satisfies. I did show that. Find the value of k. Let's plug the value of k I got back in. So k equals 20 is what I said. So 20 equals, and plug that back in, 3 answer squared minus 62 answer plus 40 does in fact equal 0. And when k equals 20, I get that 12 minus 3 answer all over 3 answer plus 4 does have a magnitude less than 1, so that is convergent. Great. And when k equals 20, 3 answer plus 4 is a, and then a over 1 minus the minus 0.75 that we found does give me 256 over 7 as the sum to infinity. Great. 10. This really is just completing the square. So 6k becomes 3k, square that for 9k squared, take that off. 2k minus 2k becomes minus k. That squared becomes k squared, take that off. So 3 plus that equals 10k squared minus 7. Cool. And so that means that the center is minus 3k and k, and the radius is the square root of this thing. Great. I don't like it, but like it is what it is for this one. So I know that the method was correct. So you plug in that y. Making sure I wrote that down correctly, which I did. You plug in that y. So 4x squared minus 4x plus 1 is correct. So 5x squared minus 4x. Let me just check. That becomes minus 4kx plus 2k plus... This is, if I'm going to have made a mistake anywhere, it just feels like it's here. Doesn't mean I did make a mistake, but I just feel it. If it's going to be somewhere, it feels like it's here. But bleh. So 2k minus 4 to x, 2k plus 8, cool. So that means b squared minus 4ac is bigger than 0 because it meets at 2 distinct points. So that squared minus 16k plus 16, good. Minus 4 times 5 times 2 is 40. 4 times 5 times 8 is 160 minus 160, good. So 4k squared minus 56k. So 16 minus 160. Oh, no, try that again. Guys, I'm so good at buttons. And then divide all that by 4. Divide that by 4. So that is the quadratic inequality. and you do sketch it, you get minus b plus or minus square root of, so 14, let's keep you guys with me. So let me just check I did that correctly. 14 plus or minus square root 14 squared minus 4 times a times c all over 2a. That is correct. And presumably, boom. So that gives me my two value of k's. I have not heard that. Sir, you know I know nothing. Hold on. On the CG50, you mean to convince me on this day that, hold on a minute. You intend to convince me, no, stop it, that you can check if your algebra is correct. How? Guys, I'm two, like, if you show two algebraic expressions that are equivalent, you get a 1, if not a 0. No, can you do that? I'll tell you what, if I was as good at my calculators as I was good at the math that the calculators do, I would be blowing your damn minds right now, but I'm not. And so what instead I'm going to do is keep you guys on the straight and narrow when it comes to the actual math. That's fascinating. How do you do that? Is that an equation? Do I go to A? Okay, I'm not going to waste people's time learning this on the spot, but like, well, granted, I'm also not going to waste my time to learn how to do that because I can't be bothered. But someone in the chat says that is the thing you can do. So if you want to be lazy, go work out how to do that. It is there to be worked out. So we got our two values of k. You plot them. We want, it's a quadratic, a positive quadratic in k, and we want where this thing is bigger than 0, so we want it to be less than the smaller one and bigger than the bigger one. And then you'll be fine. 10 minutes left in theory, but I've taken my sweet time to chat, so it's fine. This is classic. Find the initial value. It's where t equals 0. You get 10 to the 3. It's 1,000. The initial value is 1,000. A is equal to 1,000. Let me just check this point works on my model. So what I'm going to do is, if this model is correct, then let's do log to base 10 of 1,000 times 0.953 to the 3. And I should get a number very close to 2.79. I do not. Not even close. That is a problem. That is a problem. Like, that's a major problem. That's bad. Okay, so let's try this again. What went wrong here? What went wrong here is that it shouldn't have been 3. It should have been 10. It's when the x value was 10. So let's try that again. And ding, ding, ding. Okay, so great. That predicts the correct spot. We're all good. So that means my model seems okay. And I can... So V is 1,000 times 0.953 to the, what did I say, 24? Is 315, which is very close to the 320, so good. Yay. 12, I did that, it was fine, no issue. 13, find a complete equation for the model. What we can do is we can test this to make sure it predicts what it needs to predict. So when t equals 0, why don't I just plug in what I've got? So I said it was 60 minus, what did I say? 0.145 lots of 0 minus 20 bracket squared. So it starts at 2. And the maximum it gets is 60. So it starts at 2, it gets to 60. Great. So that is that is the model for A. And when t equals 40, you plug it in, you get your 2. Great. So here Let's just check this predicts the same. So it doesn't really matter what alpha is, because then it will go between, if b is equal to 31, it'll go between 60 and 2, which is what we want. So b equals 31, or beta, sorry, equaling 31 is definitely correct. And then when alpha equals, so it starts, so 29, still in radians? Shouldn't be in radians. Nope, 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 nope. Shift, nope. Shift, nope. Guys, 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 guys. How did I turn off a fake calculator? Okay, no, what? Why did it turn? Okay, we're back. Guys, we're back. Calm down. Everything's fine. Just chill. What happened is technology hates me. It's personal vendetta. I don't know why. I didn't do anything to it, and it's rude. Okay, so 29 cos of 9 times 0 is 0. I said it was 180. Alpha is 180 plus 31 equals 2. So it starts at 2. Great. And it gets up to 60. Great. So that's a good alternative model. Give a reason why, because the first model predicts that you will be a kilometer underground, which would be a very fun roller coaster. So here, prove that. I did prove that. Great. The end. And then our favorite. 7 minutes left in theory. So here, show that. I did show that because nailed it. Show that. I did show that. See, I did show that because you go vertical to the curve, horizontal to the line, and then it just works. Great. So in terms of actual checking, there's not too much I need to do here, because I just put in, let's just redo it, put in value of 1, and then just redo it. So 2e to the 3 answer minus 4 all over e to the 3 answer plus 4 equals nonsense. And I think I wrote down the nonsense. Yeah, 1.502. That is x2. And then you just click the button, and then it's 1.968 is beta. Great. Using suitable interval, show that, and I did show that because I plugged in, I'll be more explicit because I've got them as well. So you plug in alpha equals 0.4315. This is alpha equals 0.4325. I plugged it into that expression up here. Change of sign, therefore root and interval. Wait, change of sign, therefore root in interval 0.4315, 0.4325, therefore 0.43223 decimal places. So it's change of sign and it's continuous in the interval. Okay, so that is the checking complete. We've got answers for everything. We have checked everything. I'm going to lock that in. And now we can mark up. And we had time to spare. Love to see it. So marking it up. Oh, this is where I'm going to have to, let's do a split screen here. Whoop. Okay. Or in fact, let's whoop, just so I can see more of my working mark scheme. Although you're going to want to actually see the mark scheme as well as my working. So let's just sort of see what happens. So it's a little bit small, but we'll have to deal. I'll zoom in and shimmy around as appropriate. So I'm curious here what would have happened if you didn't have the plus C. So here they're saying, I'm genuinely like, oh, okay. Why is nothing moving? Okay. Okay, calm down. Guys, the tech is teching. Do we need the plus C? And including the constant. So you do need the plus C for the final answer, I think. So just note that. Limits or plus C, or you will be limited to a C. Okay, so that is our part 1. Question 2. I did show that. Great. Then you get A is 3/4 and X is plus or minus, yep, that's good. Okay. Root of 5 squared, 3 squared, 2 squared is root 38. So this thing is root of, yep, so you get that. So when A equals 5, it's 45, so it's 5. Great. So here, you get plus a half minus a quarter alpha squared equals 0, which gets you to here. Perfect. Y equals, yeah, half x plus 3. Great. Show this thing. Yep, you do your trapezium rule, and you get the equation they gave. You follow it through, you get 5 and 23. Perfect. Guys, I have the gift. I have such a gift. Technology. This is why I'm not like. This is genuinely. I tried doing research once, and like every piece of technology broke. And when I stood up to give a final presentation to let them know that nothing had worked, every projector in the building stopped working at once. Like, I am that guy. Okay, so half A. Check. A plus B, 3 plus B minus A. Great. So here, for question 7, we have it's bigger than 3. I forgot. Wait, hold on. Did I not read the question? Do you need the... Oh, man. Oh, I missed a mark here. I forgot to... No! What? Hello? What is happening? Just gonna hope that comes back. Can confirm is not coming back. Do you know what? This is a handy little PSA that perhaps, just maybe, when you get to the end of a paper and you're presenting online, it may even be a good idea to save the notes that you've made on the screen, because that way, if something like this happens, then you would be able to recover all of the things that you did. But I did not do that on this day. So we're gonna remember what answers I wrote, and just gonna do it from memory, and yep, nothing to see here. So let's go based on memory what I wrote. Here's why I lost a mark. I forgot to write the domain of this. So we knew the range of the original. I should have noted that for the inverse, the range of the inverse is the domain. Sorry, the range of the original is the domain of the inverse. And I should also have known that in the functions chapter, you cannot quote a function without giving a domain. So I should have gotten that. 15/2 I got. 2 root 6 I got. Yeah, I know. I got the 12. I got the 0.421. I got the 214. Great. This was a show that. And 256 over 7, good. K equals 20, good, because you got minus 3/4. Great. That was correct. Let's do this while my memory is still fresh. Radius is that, center is that. That was correct. I hated this, but I did get it right. 7 plus or minus root 85. 11, 1,000, 0.953 to the T. Yep, 24, 315 pounds is close to 320. Great, got that. This, I just sort of did it, which was great. Nailed it. This, 60 minus 0.15. Yep, that's exactly what I got. Height is 2 at that time. Great, I got that. 31, 180. Nailed that. Oh, come off it. Why did I press a button? I should stop pressing buttons. Let's see what they want for D. Yeah, so original model would be negative at the time. Yeah, so I got that it would be. Yeah, that's fine. So when n is even, yeah, so you do it for n equals even, n equals odd. And it doesn't really matter which one you get odd, so it's odd for all n. I got that. For this monstrosity, I want to see their mark scheme. I want to see what they did. So, oh, they did it separately. Boo. Wait, bottom, D top minus top, D bottom, all over bottom squared. No, they totally did it that way. They just did it a bit more separate. And they put it all together, rearranged, and got that. This thing equals 0, you put it in and get that. Vertical to the curve, horizontal to the line, smashed it. 0 point there, got both of those. Oh, interesting. Okay, so they plugged it into. Yes. Apologies. So I think mine should still work. But they had the equation x equals this thing. But in order to find a root, you need an equation equaling to 0. And so what they did was they needed to form an equation equal to 0 by moving this to the other side. So if they plugged it in on either side of this guy into here, they should have had a change of sign in that one. So that's what I should have done. But I did put it back into where this equation came from. So it's functionally the same thing, and I think it's okay. I will check the mark scheme, though, to see if that would have been acceptable equation for E. Yes, you can plug it into there and get a sign change. So that's fine. So I lost 1 mark on this paper, and I lost it for not giving the domain of my inverse, which is annoying, but fair. Alrighty then. So that's that. Not bad. The tech was doing some whole nonsense. But yeah. All a day's work. That question 15 was so much fun. So much fun. But right, I think I'll leave it there. I think, I think especially that 15 showed you how to brute force your way through a problem. Any mistake I make is always instructive, whether I catch it or not. So you can kind of learn like, okay, everyone makes mistakes. Maybe you learn from mine. You can add it to your bank. Keep a bank of like execution errors that you guys make all the time so that you can kind of go into the exam and know what not to do. Which is why I have my like rigid exam technique of like going through and then checking that I've answered every part of every question and then check the answers by plugging them back in, spotting any execution errors that way. It's usually very helpful. Also picking up on what I was doing there with like my sense check as I was moving through the paper, like was I ever like, oh, that seems off, and therefore catching a mistake. All top tips for you guys to pick up and use on your own. And as you move through, sort of getting more past papers under your belt, knowing exactly what you're going to do when you enter the exam room, just so you go in with complete confidence. But right, I'm going to leave it there, and I will see you guys probably on Wednesday. Probably not going to be doing if I do a live solve during Easter, it will not be at the usual time because my mornings get a lot busier. So hopefully you guys will be able to sort of join live as opposed to it being like smack bang in the middle of your school day. Can you imagine? So yeah, I will see you guys on Wednesday. We will be going through gas laws in physics, and then we'll everything's up in the air, and we'll see what happens in Easter. But in the meantime, have fun, keep working hard, and I'll see you there. All right, take care. Bye-bye.